Good morning, my dear friends. See in the last class we have seen case one wherein it was small ratios of MD by MT. Am I right? In the sense, it was MD by MT ratio was less than zero point 0.2. Am I right? Now we shall pass on to this case two, wherein we are seeing how to deal with large ratios of MD by MT. Okay? Well, large ratios of MD by MT means either MD by MT is greater than zero point 0.2, greater than zero point 0.2, or what happens is when MD by MT ratio is greater, Baba, then what happens is sometimes the eccentricity, whatever you are going to calculate, Baba, it will go beyond this section. Beyond this section. Say, take for example now, okay? This YB value is now, say for example, YB value is now 250. Assume that YB value is 250. But now, if your eccentricity calculated works out to be 350, Baba, you have to keep, if eccentricity is 350, then you cannot keep this pre-stressing steel inside the concrete. It will come beyond here now. Am I right, sir? Now it will locate your CGS beyond your section. Am I right now? So now in such cases, Baba, what happens is now in such cases, uh, the bottom fiber stress becomes very very critical in initial condition. Okay, so now we'll try to analyze the bottom fiber stress in the initial condition. Okay, so now here, as usual, I have drawn here now YT, YB I have shown, KT, KB I have shown, CGS I have shown. So this is your eccentricity, this is your overall depth D. So now here I have drawn the stress distribution diagram in the initial condition. Okay, in the initial condition, you know that F naught is going to act at the CGS. Okay, and C force will act at your bottom kern point. Okay, so now since our CGS is going beyond the section, I have to keep it inside the section. Am I right now? Inside the section. At that time, your bottom fiber stress will become more critical, okay, in initial condition. So now we'll try to analyze now bottom fiber stress now, FB. Okay, so now bottom fiber stress FB can be written as, okay, F naught by AC. Okay, now I will apply the general rule, F by A plus or minus FEY by Y by I plus or minus MY by I. Am I right? So the same thing I am going to now apply. F naught by AC plus or minus FEY by I. In the sense, F means F naught, E is E, Y means it is YB, because I'm trying to calculate the bottom fiber stress. Am I right? YB divided by I plus or minus My by I. Baba, M means it is MD, because we are in the initial condition. Only your dead load is now acting. So it is MD. Y means YB divided by I. Am I right? So now I will try to incorporate the values for E and YB. Baba, I will keep this F naught by AC as it is. Okay, plus F naught as it is. Since eccentricity E is below CGC, I have to attach minus sign to it. So I have attached minus sign to E. Am I right? And since YB is below CGC, Baba, again I have to attach minus sign to it. Okay, minus YB. I as it is, plus MD as it is, I as it is, and again YB will take a minus value since it is below CGC. Okay, so now, Baba, this minus will become plus. Okay, so it will become plus. Here minus is there, so it becomes a minus MD YB by I. Am I right now? Very simple steps. Okay, so now F naught by AC as it is, F naught EYB by I also I will keep it as it is. But now here I will multiply this term by AC, divide it by AC. I don't think any change in the value exists here now. Okay, into AC divided by AC, no change in the value, minus MD by YB by I as it is now. Okay, here what I am going to do is now I will multiply this term by F naught by AC again multiply it by AC by F0. Okay, AC can be get cancelled, F0 can be get cancelled. Under any circumstances it is not going to alter this value. Am I right? F0 by AC into AC by F0 I am going to include here now, because it is not going to alter this value. Okay, why I am doing this is only for our convenience and to make to turn it out into a equation form. Okay, so now here in this equation, F0 by AC I will take it common. Okay, so from here F0 by AC, if I take it common, 1 will remain. Okay, here also F0 AC is there now. F0 by AC I have take it common, so I will be left with EYB AC by I. Just check it up. Minus F0 by AC I have taken it common here also, so I will be left with MD by YB by I into AC by F0. Am I right? Okay. Now F0 by AC as it is, 1 as it is, plus. But now here I will take YB AC by I common. Here also YB AC by I is there. I will take common. If I take common, I will be left with E minus MD by F0. Am I right? Then next step is now, I will keep this also as it is. Okay. Next step is now F0 by AC as it is. F0 by AC I will keep it as it is. 1 also as it is, plus YB by AC. Instead of I will keep it as AC R square, because you know that I can be written as AR square also now. Am I right? So instead of I have written AC R square. Am I right? E as it is, MD by F0 as it is. Okay. Then I will go to the next step now. FB is equal to F0 by AC as it is, 1 plus YB. AC will get cancelled. I will be left with YB by R square into E minus MD by F0 as it is. Okay. But now since we are not allowing any tension in concrete, okay, KT value is equal to R square by YB. As you know, R square by YB will give you KT value. Okay. So here now YB by R square is there. So it will become, KT value will now become here 1 by KT. Am I right now? YB by R square I can write it as 1 by KT. Am I right now? So now FB as it is, F0 by AC as it is, 1 as it is. Okay. So now here E minus MD by F0 as it is. Now YB by R square will become 1 by KT. Okay. So I have written it here now, this thing now. But as you see now, this bottom fiber stress, okay, under any circumstances it should not exceed FCCI value. Am I right now? Because we are analyzing the initial condition. Okay. In initial condition, okay, our this thing okay, in initial condition, under any circumstances bottom fiber stress should not exceed allowable compressive stress in concrete in initial condition, FCCI. So I will equate it to FCCI. Oh sir, no. So now from this equation I can easily calculate AC, in a sense area of concrete required in initial condition. So now if you rearrange the term, you will get this equation. Okay. So now this equation gives you how much is the area of concrete required in initial condition. So you can easily calculate it. And area of concrete required in the final condition can be calculated as previously. This equation we have already proved it now. Okay, AC is equal to FED divided by FCC of YB. Okay, so now by using, whenever the MD by MT ratio is more, okay, AC in initial condition can be calculated by this equation. AC in final condition can be calculated by this equation. Okay, so now this is how we are going to design the pre-stress concrete members. So now in the next class we'll try to take up some problems and use all these equations, and we'll try to design the pre-stress concrete beam. Okay, thank you very much.